we introduce reVISit, looking under the hood of interactive visualization studies. It is no surprise that well-designed interactions can improve the way that people use data visualizations. But how do we assess the impact that interactions have on performing visual analysis? For visualizations with few interactions, data analysts can design the study to control for the effect of each one. This can be useful in understanding how each interaction affects a user's accuracy or speed when completing a task. However, for more complex interactive visualizations, it becomes harder to control for all possible forms of interaction. Additionally, participants can use different analysis strategies or sequence of interactions to solve a given task. This leads to the question, how do analysis strategies impact participant performance when using interactive visualizations? To address this, we propose a new study workflow that allows researchers to better understand the effect interaction strategies have on user performance. We implement the data analysis methods in this workflow in an open-sourced, web-based tool, reVISit. reVISit provides support for analysis of both qualitative and quantitative results, as well as provenance visualization through event sequence mining and playback of participant sessions. Let's take a closer look at reVISit in action.
Heather is a researcher who recently ran a user study analyzing the performance of network visualizations. Her study compares node-link diagrams to adjacency matrices for finding paths in a network. During her study design, Heather had to balance the interactions available between both node-link and matrices to not unduly favor one condition over the other. An important part of finding a path in a network is being able to identify neighboring nodes. In the node-link, this can easily be done by clicking on the node to highlight neighbors. In the adjacency matrix, Heather added an interaction that highlighted neighbors in green when a user clicks the column label. Now, she wants to be able to assess whether or not this added interaction actually helped improve performance for the adjacency matrix. Heather moves over to the reVISit system and homepage. Here, she can see a high-level overview of how her participants performed on each of her tasks, as well as the main interaction patterns used in those tasks. Hovering over the interaction patterns, she notices that users who used the column label interaction performed at around 70% accuracy comparatively to the 60% accuracy without. She wants to drill down into this a little bit more. So she goes over to the task analysis pane and then first groups on condition. Then she wants to group upon whether or not a user used the column label technique itself. Grouping on that and expanding the columns, she can see that users of the column label interaction technique have a 67% accuracy compared to a 45% accuracy for the participants who did not use the column label technique. Having validated that there exists a pretty large difference between the accuracies of individuals who use the column label and don't, she wanted to drill down into exactly how those individuals who don't use the column label go about solving this task for adjacency matrix. As she's interested inside of the answer that they gave as well, she unhides that column and then scrolls down to look at how the individuals who didn't use the column label approach this task. As she scrolls down, she sees a fair amount of these answers of M views. As this is an incorrect answer to the problem, she delves in to the playback interaction to see how users are using this to solve the problem. Playing through each of the strategies, she sees that the users search and then select for M views, which is located right in between Lane and Rob. Interested by this, she sees that likely what is occurring is users are looking directly in between Lane and Rob and selecting the node that exists between them that is an institution, which corresponds to M views. This represents a conceptual misunderstanding of how edges are visualized inside of an adjacency matrix.
This methodology was employed to analyze data from 2 published crowdsourced user studies, which we present as case studies in the paper. The combined analysis of study results with the interaction patterns helped our analysts uncover novel interaction strategies, identify gaps in participant training, and measure the impact of design decisions used in the study. You can check out reVISit at this URL. Thanks for watching our video.